Hello there, ladies and gentlemen, and today we are taking a look at this very nice building of 690 of the office of Charles F. Blasier, and it has this very nice facade, which we kind of saw before as well, that has this kind of net thing, kind of like a bird's net. And in our script, we are able to actually go through this, and we have single pieces that we can actually choose from, as you see here. And actually, if you would give those things to a person that would like say, hey, you know, I want to cut it out, it would be actually possible to do so, because when we are looking at the pieces, you see they have like single pieces that they can basically be laser cut out or be like made that way. So that actually would be a thing that could be realized with those data that we created here. So let's get into it. Great, everyone. So we're just starting with the completely new Grasshopper file, and I kind of want to show you how we are going to do that. So I'm just gonna sketch out a little bit how we want to make this work, okay? So first of all, we're just starting with a very plain rectangle like that. Then this rectangle has certain points. They are just like around this curve here. Oh no, we actually do it different, to be honest. We have this thing populated with random points around all over it. Those points that will then be connected between each other like that in a random manner all the way around. And then they will be extended by a very large amount. So they go over the edge like that. And when they are then extended by that much of an amount, we make them as well a little bit like thicker. So they're normally like that, and we want to make them thicker like that as well first. And not only that, but we also then, when we have that done, we want to basically cut the piece into several pieces like that as well, so we are able to get like those production ready pieces that we can use for our for the thing that to actually be produced or 3D printed or engraved, anyway, like in just one of those ways of doing that. Great. So we will just start with a simple rectangle. And we have an X size and a Y size. And we just, by the X size, it's gonna, in my opinion, be the width, and the Y size would be the height, because we kind of have to, we want to then as well, like move it over like that, right? So we just start like with it on the plain floor, and then we will move it over. And then we also have the height as well, like this. So we do height. I do it in meters, okay? Just so keep that in mind. And we do the width in meters like that as well. And great, so now we have the height and the width a little bit like that. And we want to now populate just random points in there as well, like populate 2D rectangle, put it here. Then we want to actually partition the list into sizes of 2. Thus, we would get a pull line that can be created through like the 2 pieces over time, as you see here now. So now we have already our random kind of pieces around this place as well. Great. There will be, yeah. So we want to you extend those now, and when they extend it, there will be an issue coming later as well, with which we kind of want to resolve later as well. I will just mention it here like for the moment. But as you see, there are sometimes a lot of curves who are intersecting with a lot of other curves. And sometimes this would not look that correct. So we might need to adjust something in the later hands as well, for it to look a little bit more kind of not too randomized, but like a little bit of a way of adjusting it as well. Cool, now we have our extended curves, and we want to offset them as well, just with offset curve command, and give them an offset distance. Yeah, maybe not 1, but it's fine. Offset distance. And we need to do this actually twice, because one time in the positive and one time in the negative. And so we have those two lines here, and we use the distance of this one and expression, like click on expression, do -x, so then it's going to that direction. And now we have our nice kind of pieces in here as well that like shows the thickness of those things. We're gonna hide this now, and we're also gonna use the endpoints of those things, like here and there. And we're gonna put a line through it as well in order for the ends to be connected together like this. Here, you see. And we put this for the endpoints as well. And then we just merge those things together, like the polylines, the offsets, I mean, with the line and the offset and the line. And then we just join those things together within the curve commands. Here, join curves. And now we have a list of, like, it's always like this. Before it was 4, and now it's just 1. And because I want to keep this thing a little bit tidier, I just with Shift, Control, click, put them over here, and those with Shift or here. And now I want to just make it in a cluster so it's a little bit more tidier as well. You see, now we have it all in this nice cluster, and we don't need to worry about it anymore. Great. Now that we have that, we need to create the region that it's gonna be like residing in as well. So there are several ways to do it. Actually, let me quickly check of how I made it over here. I made it with the region difference. I guess that makes sense. So we do region intersection. Yeah, intersection between the curves that we have here and the curves that we create here in the beginning. And this should give us, yeah, now just the inner workings of that curve, which is great. And I guess we can also, I wonder if I flattened that one. I guess I did, but that doesn't really make sense why I did it though, but that's fine. And now we have our inner parts. So exactly how we wanted to have them. I'm just gonna hide those so we can see it a little more clearly. And now that we have that, we also want to basically join them together as well. So if I just put like that and I will just flatten them, you see it should create a very nice kind of like grid mesh around it, which works really, really well for us at the moment. That's pretty good for now. And we also want to, I would like to create a, let me actually take a look how I did it before, because otherwise we just go around in circles and we never really get where we want to go, which is not really what I want here to happen. So we do the region, like trim with region, have the curve here and the region off here at the beginning. And this should give us, I think, or doesn't give us actually anything at all. And it's just gonna be one entire piece of polyline curve. But we also have to, anyway, I want to actually offset this curve here by the amount that we created here before. And do it also with a negative as well. Whoops. So like that. And that can be, yeah, and I guess then we can do the point in region, or the trim with region, trim region. And use the region that we defined here and the curves here. And now we get the outside and insides of those curves. Like that. You see, it gives us very nice things. However, we kind of have the problem now that it doesn't really, it's kind of, they don't end. So if, for example, you see, we want them to end as well at the correct points. So we can do that by, because we always need to connect the endpoints here together. You see, like this curve goes like that. And if it's open, we need to connect it together. Like this says here as well. It's open, we have to connect it together. So we're going to use the periodic, or we need to first check if the curves is closed or not. And we use this command here under analysis closed. And we then give get information if this curve is closed or not, as you see here. And we're just gonna actually flatten this as well. And we have those curves who are closed or not. And we only want to use the not closed curves and use it as a dispatch pattern, and then actually close them as well. So we're just gonna use this as a dispatch pattern, use the curves here, and then we use those endpoints of those curves, like you see here, not the other ones. And we're just gonna put a line through those start and endpoints, like that. Like this, and you see it creates a very nice curves for us here, and you're just gonna merge them together as well. And we're gonna use also the beginning curves here, so then we have very nice set of curves that we can work with. Great. Now that we have that, we have a very nice like set of like things that we can use here. One thing that's kind of missing though, yeah, we also need to take the beginning curve that we had here. Great. And now if you use a boundary surface, it would create, after some calculation time, a very nice kind of grid over it as well. So this is like a really smooth kind of grid that we have taken like at this place here. Now this kind of actually almost does it. However, one thing that is kind of a little bit annoying, in my opinion at least, that we have those lot of intersecting things here. And a way to go around it, we just need to check how many times a curve intersects in our case here. So that's basically comes in here, like in between, because you have those curves that we created here, right? Or no, actually it goes over here. We have those curves here, and we want to see how many times a curve intersects with any other curve. So first of all, we're gonna flatten that. I hope this doesn't ruin anything else. No, it doesn't. Great. And we're gonna use intersection, like with multiple. Like that. I hope that's gonna be fine. Oh yeah, we use this like with multiple intersections, yes. And then we're gonna use the closest points on curve. So curve closest points, curve closest points. And then we're gonna use those points here and the curves that they are the closest on. And this will need to be grafted, or the other one we will see. Otherwise we need to maybe check this back and forth. Currently not sure which one needs to be grafted or not, but I guess this one then, I guess. Let me just check the distances. Yeah, this looks kind of fine, I would say. Yeah. And if the distance then is smaller, and you could also do it in Python, but in our case I just want to do it like normally, like this, is smaller than like a very small amount, then the curve in our case that's intersects, you know. And then we give a value of trues and false because of that, you see. And we just mass addition those true and false values together, and they actually would result in a massive amount of like how many of those things total are happening. And yeah, this is what I thought. We actually need to graph the curve, not the other one, not the points. And now we're getting the true amount of how many times each of those curves is actually intersecting another curve. And depending on that, we also do like a smaller than value. So like if the number of intersecting values is smaller than, let's say, 25, we giving the curve permission basically to be moved for the next kind of curve like this. And we just can flatten this as well here. And now we get two values. So you see, it gives us two values out that are not like, say, worthy. Like this would be like those four here. And the other ones can, obviously, if we would decrease the value, it would be more curves. And if it would be more value, it would be more curves. So intersection value. Great. And now I want to put this into the curves that we created here. Well, the other one. And now we have our Very nice adjusted grid that kind of doesn't intersect as heavy anymore as we had it before. That's great. Cool. And now that's basically already quite far how we've gotten. That's great. However, there's one last thing we want to do. So I was talking before that they kind of have this like each pieces that go like with the facade, right? So it's basically intersecting. And I could imagine that they kind of used maybe like they had like a big plate and they had like a laser cutter going over it and then getting out this like facade. So what I wanted to do is basically give the CAD data that you could maybe send to those people so that their laser cutter can be used in that sense, you know? So we are using just, we basically need to cut those things open. So we do this by dividing the curve that we create here in the beginning. So this curve here, you can explode it, and then it gives us 4 segments, and those segments then need to be like chosen. And I choose just the first one, so number 0. And this gives us that curve here. And we want to divide this curve by like some amount. I guess it would be like a rather small amount. And we're just gonna create a line going upwards like SDL like that. But we need to go it to the Y direction, into like this direction. And we need to have the length of the Y side. So it just creates it like all over like there. Great, now that we have that, we just need to do a simple, it's under physical surface split, and we use those curves here, and we use the surface that we had created over there. And this then gives our very final result that we wanted to have before, that we can basically choose between the pieces as well. So that's pretty great. And there's one kind of cool but also not good thing. So for example, you want it to be always one piece, right? If you have the curve, if there are 2 pieces happening, you see like those ones here, you kind of could get in trouble. I guess it can still be built, but those will be then 2 pieces. So you kind of have to like play around a little bit, like with the curve intersecting, with the offset distance, with the how many curves you're removing, and then you kind of get something more to your liking, because like you need to, it's possible to just play around a little bit with it and then, you know, get a perfect result like this one. I guess they're all each pieces, but if there are 2 less of any amount of curves, you might need to increase the amount of divisors, for example, of the divisor panels. And obviously, the great thing is you can just play around with it all the way from the beginning and go back and forth. It's like really, really good. And then we just also gonna extrude the curves to give a little bit of thickness and also a custom preview. To just kind of like make it a little bit more visible for the people as well. So we need to use the geometry like that and have a small thickness to it like that. And this will be then our whole amount of pieces. And yeah, that's kind of that. Let me actually make this a little bit smaller. Yeah, and that's basically that. And if you just want to choose one of them, just go here, and then you just have one that you choose from. Whoops, not this one. I meant to do that one here. And here you basically literally have the obviously you can still adjust those things a little bit the way you want it. But you have a usable CAD file that you can 3D print out. You can use it for something else. You can, you can just play around with it and put it all together. So yeah, and with that said, thank you very much for watching. I hope that helped you around to get this kind of 690 building by the architects. Great building, Folsom Street. To be a reality in your project. And maybe something similar can be done as well. for your things. So yeah, have a great day. Hope you learned something, and see you in the next one.